Okay, good morning, afternoon, whatever the case may be. My cat Cleo wanted to say hi as well. That's her yelling in the background. I assume she'll be making numerous appearances during this video. So, in order to do this, what I was originally going to do all of them, and then I thought that might be a little bit too generous. So I'm thinking I'm just going to do the evens. That way you guys have a good idea of everything going on. And that still gives you plenty of ability to practice on your own. And also dissuades you from using this as just a blanket copy mechanism as a way to just finish it. So we have 2 pages, and these 4 right here, 21 through 24, you just skip. So right away, there's 4 freebies. So 1 through 10, those are just standard solving quadratic equations using square roots. I did a little bit of this yesterday. 15 through 20, those 6 are going to be all involving imaginary numbers. So let's go on. So starting with number 2. So our goal in any of these is to get that x by itself, that x squared by itself. So what we're going to do, hey Cleo, see, there she is again. We're going to divide by 25. And this gives us x squared equals 4 over 25. Now 4 over 25, you can't actually do a whole lot with that. So can't reduce it at all. If we could, this would be the time to do that. Instead, we still need to get x by itself. X isn't by itself right now. It's x squared. How do we get rid of squared? Well, roots and radicals are the inverse of exponents. So what we're going to do is we're going to take the square root of x squared. Now if we do it to one side, we do it to the other. So if we square root one side, we have to do the same mathematical operation to the other. So this is going to give us x equals plus or minus the square root of 4 over 25. Now again, that doesn't really do anything. We now, instead of having 4 over 25, which we couldn't reduce, we now have square root of 4 over 25, which we also can't reduce. So this is where we want to go back to the rules that we had, I believe it was on Monday. Remember, I said that the square root of a, or maybe it was x, I don't remember, equals the square root of a over b, and it also works this way. So what we're going to do is we're going to take the square root of 4 over 25, and we're going to make it, hey, the square root of 4 over the square root of 25. Now, if you know what those are, great, move on. The square root of 4, well, that's 2 times 2. Remember that if we have one pair underneath, we get to go 1 on the outside. If we take both of those out, there's nothing there. Square root of 25. 25 is not a prime number. Is it divisible by 2? No. By 3? No. By 5? Yes. That gives us 5. 25 divided by 5 is 5. And so that pair of 5s makes 1 on the outside. So we end up with plus or minus 2/5. If you wanted to, you could go back in there. 25 times 2/5 squared, 4/25. That cancels out. We get 4. So you can always go back and check your work. So let's move on to number 4. Ooh, yay! A fraction. Really doesn't make that big of a difference, as you'll see. Again, what we want to do is isolate our x. So we're going to start off by subtracting 14 from both sides. That's going to give us 1/3 times x squared equals 26. Well, 14 minus 14 is 0. So that means the 1/3 x squared is all by itself on the left-hand side of the equation. Then we have 26 minus 14, which is 12. So what we're going to do now is we're going to take this and we're going to multiply both sides by 3. Because 1/3 multiplying by 1/3 is the same thing as dividing by 3. So the way we get rid of either one is we multiply by 3. 3 times 1/3 is 1. 1 times x squared is x squared. 12 times 3 is 36. So we're going to take the square root of both sides. Always remember to drop that plus or minus there. We end up with x equals plus or minus the square root of 36. Now, if you know that the square root of 36 is 6, great. Do it, move on. Let me show you how that would work doing it with factoring. 36 is not a prime number. So we go 2 times 18. 18 isn't a prime number. That gives us 2 times 9. I'm going sideways here. 9 is not a prime number. It's not divisible by 2, but it is divisible by 3. So we have 2 times 2 times 3 times 3. We have a pair of 2s and a pair of 3s. That gives us 2 times 3 on the outside, or 6. So x equals plus or minus 6. What? Cleo's back for round 3. Hey, baby girl. Call her baby girl. She's like 11, 12 years old. Anyway, so here we have 9x squared minus 1 equals 63. Same general idea. We're going to add 1 to both sides. What, sweetie? What? So we divide both sides by 9, and we get x squared equals 64 over 9. That gives us the square root of x squared equals plus or minus the square root of 64 over 9. Now again, there's nothing we can reduce there. If we could reduce now, we would. But instead, what we're going to do is we're going to go the square root of 64 over the square root of 9. And as we do square roots and as we move through the rest of the year, I really want you guys focused on identifying up to like 12 or 13, really, the perfect squares. 1 squared is 1, 2 squared is 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100, 11, 121, 12, 144, 13, 169, 14, I believe is 216, but I have to go and double check on that. Yeah. but definitely like 1 through 12. And if you do that, you'll see that in cases like this, you can really shorten your workload when you have those two perfect squares. On to number... notice that I'm just going to show you how to do 64 the long way. I won't do 9. We've already done 9. But if I have 64 here, that just gives me a whole bunch of 2s. Six to be precise. So you could say that 2 to the 6th power is 64, and you'd be correct. Well, notice here we have 1, 2, 3 pairs of 2s. So 2 times 2 times 2 equals 8. Okay, 8. So here we have 5x squared equals 90. Nothing to add or subtract, so we're just going to divide. And we get x squared equals 90 over 5. Now, remember how on a couple of the earlier ones, number 6 and then number 2, I believe it was, we had fractions that we couldn't reduce at all. Well, here we have a fraction that we can reduce. Plug 90 divided by 5 into your calculator, and you get 18. So now we're going to square root both sides. And we get x equals plus or minus the square root of 18. Now 18 is not a perfect square. 3 squared is 9, 4 squared is 16, 5 squared is 60, or 5 squared is 25. So we'd end up here with 18, we'd end up with like 4 point something if we plugged it into a calculator. But we don't want a calculator, we want the reduced form here. So we're going to go the square root of 18. So we can pull a 2 out. That's 2 and 9. Now 9 is not a prime number, but we can't pull a 2 out. Can we pull a 3 out? Yes, we can. So that's 3 and 3. So the square root of 18 we're rewriting as 2 times 3 times 3. Now these two 3's, one pair, we can move to the outside. So we have 3 radical 2. So that gives us a reduced version of x plus or minus 3 times the square root of 2. Now these are not to be done just by plugging stuff into your calculator. Notice it says solve each equation using the square roots method, and I want your answers to be in reduced radicals. Okay, number 10, the last one on the front of the page. Well, the last one I'm doing for you. It's also the last one. Hopefully you've been doing the odds alongside and only using these if you get stuck. We're going to subtract 4 from both sides. That gives us 3x squared equals 4 minus 4 is 0. 166 minus 4 is 162. We're going to divide both sides by 3. That's going to give us x squared equals 54. Now we're going to square root both sides. Remember, we always want to drop in that plus or minus. So we end up with x equals plus or minus the square root of 54. Okay, so let's do the square root of 54. Is it a prime number? Nope. Can we divide it by 2? Yep. 2 and 27. 27, not divisible by 2, but is divisible by 3. 3 and 9. 9 is 3 and 3. So instead of the square root of 54, we have the square root of 2 times 3 times 3 times 3. We have this nice pair of 3's here that we can move out. We end up with 3 times the square root of 2 times 3, which is 6. If you ever want to check your work, just grab a calculator, hit square root 54, enter. Take note of that answer, and then go 3 times square root of 6, enter. It should be the exact same number. So this gives us x equals plus or minus 3 radical 6. I'll draw a better 6. And again, if you wanted to, you could go plug that number back into this equation right here. And that would make it true. Okay. Number 16. Now, clearly, we didn't jump from number 10 to number 16. This is a different assignment. This is one where we are going to be utilizing imaginary numbers to solve our problems. Like our math problems, not like hunger or, world peace or, mental instabilities or anything like that. So we end up with negative 50. So now remember that when we are square rooting this, at this point, we should be able to look at this and go, hey, that doesn't work. At no point will this line actually cross the x-axis. At no point, there's no number I can stick in there that will make negative 3 times x squared equal to 150. So what we do, remember, is now we're talking about complex or imaginary numbers. We have the square root of negative 50. The first thing I want to do is, again, go back to my rules and remember one of the rules we had was the square root of a times the square root of b equals the square root of a times b. And that also works the other way. Well, if I'm going to rewrite negative 50 as 50 times negative 1. Then I'm going to break apart the square root of 50 times the square root of negative 1. Well, what is the square root of negative 1? It is I. So now this then becomes plus or minus I times the square root of 50. 50, not a prime number, is divisible by 2. So we go 2 and 25. 25, not a prime number, not divisible by 2. Is it divisible by 3? Nope. Is it divisible by 5? Indeed it is. So we have 2 times 5 times 5. These two 5s right here, because that's the square root of 2 times 5 times 5, we're going to take, because we have that buddy system going on, those pair of 5s, we're going to move it out, and that gives us 5 radical 2. So we're going to take this part right here and join it up with that I we already have. So this is going to give us x equals plus or minus 5i times the square root of 2. Okay. On to number 18. We only got 2 left. So what we're going to do here is we're going to subtract 18 from both sides. Divide right here. We get negative x squared equals 39 minus 18 is negative 21. positive 21. Just good old 21. Okay, now we got to go to that negative. So what we do here is we're actually going to times both sides by negative 1. Because we can't take the square root of that negative number. We need to get the x squared by itself. And we should see where this is going. We'll square root both sides. So we end up with x equals plus or minus the square root of negative 21. Now, when I'm doing a factorization of this, first thing I want to do is break this apart into negative 21, the square root of, not negative 21. The square root of 21 times the square root of negative 1. Why do I want to do that? Because now this becomes I. 21, is that a prime number? No, it is not. Is it divisible by 2? No, it is not. Is it divisible by 3? Yes. Yes, it is. Is 7 a prime number? Sure is. So 21, there's nothing we can actually pull out. There's no pair of 3s. There's no pair of 7s. So the only thing we can really reduce it with is this I right here. So with x equals plus or minus I radical 21. And number 20, last one. Hopefully, again, you've been doing the odds as we've been doing the evens, taking your time, spreading it out. So let's solve for x squared. We're going to add 15 to both sides. That becomes a 0, so we end up with negative 4/3 times x squared equals 216. So in order to get rid of a fraction, we multiply it by its reciprocal. So negative 4/3, what we're going to do is we're going to multiply that by negative 3/4. What's up, Cleo? So the 3's cancel out, the 4's cancel out, 2 negatives become a positive, so we end up with x squared over there. Well, we got to remember, if we do it to the left side, we do it to the right. 1. So we have 216 times negative 3/4. Mama, what you doing? One. So we're going to go 216 times negative 3 divided by 4. That gives us 54 times negative 3. So we're going to get negative 162. We then take the square root of both sides. Again, the reason we do this is to get rid of that square. And then we're taking the square root of negative 162. Can't forget that negative. So we're going to do the square root of negative 162. First things first, I want to break this into the square root of 162 times the square root of negative 1. Again, the reason I do that is because I can convert that negative 1 into an I. I never have to worry about it. We're done with that now. So now all we have to do is find the square root of 162. Prime number, it's even, so I know it's divisible by 2. What, Rama? Okay, hold on just a second, everybody. Okay, sorry about that. My dog was just having an issue that I wasn't going to bed yet. So, 81, if you know what the square root of that is, great. You can move on. We're going to go the methodical way. 81 not divisible by 2. It is divisible by 3. That gives us 3 and 27. And remember, at any point we can multiply all three of these together. 2 times 3 is 6. 6 times 27 would give us 162. 27 is divisible by 3. That's 3 and 9. And again, if we went 2 times 3 times 3 times 9, that would give us 127. 9 still divisible by 3. So this is our prime factorization right there. So instead of the square root of 162, we're going to go to the square root of 2 times 3 times 3 times 3 times 3. We're looking for pairs. We have 2 pairs of 3s. So we pull out both of them. 3 times 3. So that's going to give us 9 radical 2. We can't forget the I. So we have our plus or minus. We have our 9. We have our I. We have our radical 2. And that's the answer to number 20. Let me quick look at the other ones. If you're following the steps that we did on the evens, the odds shouldn't be that much of a difficulty for you. I will do. Let's quick do number 5. Just because I think that might be an issue that people might have. If I add 3 to both sides here, watch what happens. I get 2x squared equals 0. Divide by 2, you get x squared equals 0. Square root both sides, and I get x equals 0. Notice I don't put a plus or minus there because I can't have a positive or a negative 0. So hope this was helpful. Good luck on the rest of them, and I will see you all tomorrow.